People often wonder about the difference between code health and traditional static analysis tools. The first part of the answer to this question is in the very idea of code health. CodeScene specifically talks about code health because we are looking at the human side of code. In other words, we're looking at maintainability, how easy it is for developers to understand the code, to read it, and make changes that are low risk. If code is healthy, it means that feature development can go faster and is safer. These qualities depend on the code being easy to work with, and that's what code health is all about. Let's take a look at a codebase. This is a code health system map. The colored circles represent each file in a codebase. The color here in this view shows the code health of the file. So red is unhealthy code, yellow is problematic code, and green is healthy. And this is, at this point, a static analysis. CodeScene simply analyzes each file, but using these metrics that are oriented towards maintainability and ease of working with the code. So this is a static analysis at this point, but with this important difference. The second part of the equation for code health is that CodeScene also mines the Git history of a project. This allows us to layer in behavioral data because CodeScene can tell when each change was made, where it was made, and who made it, and over the entire history of a project. One of the kinds of analysis that we can do based on this data is hotspot analysis. So in this version of the system map, we're looking at development activity. Here, we can see each file, and its color is based on how many changes have been made to that file. The darker red files are the most active ones. That is where the developers in the project spend most of their time. As you can see, there are far more pale-colored files than there are dark ones here, which means that developers tend to spend their time in a limited number of files. CodeScene uses this information to allow you to prioritize your refactoring efforts. This is where the magic begins to happen because we can combine the code health analysis in this view and hotspot analysis in this view, which we call refactoring targets. Now we are looking at the intersection of high development activity files from the hotspot map and low code health files, and this narrows it down to these roughly 10 or 12 files that are refactoring targets. What this means is, this is where any refactoring effort would have the most benefit for the project. Since we know where the developers are working, we know where the benefits will occur if those files can be fixed. And because the code health metric is specifically looking at the ease of working with the files, this means that we can improve the experience of the developers and their efficiency by improving these files. So ultimately, this will benefit the entire project, possibly freeing up developer time as these files become easier and easier to work with. As you see, we've narrowed the number of files to improve, down from hundreds of files to a small number. So what was originally a massive haystack of possibly problematic files to work on is now a limited number of files that we can suddenly turn into individual tasks and realistically start to fix. This graph shows all the files in a software project grouped into buckets of 12 files. They're sorted by the number of changes made. And it's interesting to note that every non-trivial project has this same shape. This power law curve, where a small number of files on the left occupy a very large amount of development activity and a long tail of files with low activity on the right. In this project, we can see that while there are a lot of changes being made in the green code, some of the most active parts of the project are actually in red code. And if we zoom in a little bit, we can see how the 3 most active files in this project are in a problematic state. This means that the places where a majority of the commits are being made are actually very difficult to work with. This is something that slows down development and makes it more risky to make changes. We can compare this to the work environment of the developers. They spend lots of time in these problematic files, so anything that's slowing them down and making their lives difficult here has an impact on the evolution of the project. So these are the key differences between how CodeScene analyzes code and how traditional static analysis tools work. CodeScene's code health metric is based on code smells backed up by academic research that shows correlation between these code smells and negative outcomes. Further, we have done our own research that shows how low code health, that is, all of these factors working together in the analysis, does in fact lead to slower development and more bugs, whereas healthy code leads to faster development and better outcomes in terms of bugs. The code health metric, combined with behavioral data that we layer on top through the idea of the hotspot, gives us the ability to prioritize the most important parts of the codebase to refactor in order to improve the working environment of the developers and have positive outcomes for the project. CodeScene's pull request integration is one of the ways CodeScene can help developers write code that will be sustainable and help the long-term success of the project. Let's take a quick look. Here's a pull request where CodeScene has detected an issue. Quality gate has failed and 8 findings are declining code health. It looks like it's one method causing these problems. These are the different code smells that CodeScene has identified. We can then look and see where these issues are occurring. Here's the method that introduces these problems, and by preventing these issues from reaching the main branch, we're ensuring that the code health of the entire project will no longer decline. Stopping the decline is the first step in improving the code health of a project. There's a lot more to CodeScene than what we've seen in this video, but hopefully this explains why CodeScene represents the next generation of code analysis tools. By going beyond the code itself and incorporating the human factors involved in software projects, CodeScene makes it possible to consider the sustainability of the project as a whole. Software projects don't fail because they are technically impossible to fix. They fail for human reasons because the code has become too expensive and too difficult to maintain,